Since we didn't do these two in class on Thursday, I said I'd make a video that covered number 4 and number 5 in the section 5.5 live streaming notes. And I also said that if you can do 3, you can do 4, because the work that you have to do to get 3 to the point where you can start thinking about breaking up the number line, it's already done number 4, because you've already got the 0 on one side and you've already got a single rational expression on the other. Not only that, but its numerator is already factored. So with number 4, if we set the numerator equal to 0, then we'd have 2x minus 3 times x plus 1 equal to 0. And so that would mean that what we're going to have is either 2x minus 3 equals 0, or x plus 1 equals 0. So if you solve the first one, you'd get that x was 3 halves. And if you solve the second one, you'll get that x is negative 1. So we're going to need those. And then we're going to set the denominator equal to 0. So then we're going to have x minus 7 equals 0, but that just means that x equals 7. So then our 3 numbers that we have to use in order to break up the number line are going to be these two, 3 halves and the negative 1, and then we're going to need this 7 right here. All right, so if I draw a number line, let's see, I guess going left to right, the smallest one is going to be the negative 1. Then we're going to have a 3 halves or a 1.5, if you want to call it that, either way. And then up here somewhere we're going to have a 7. I'm not worried about getting this to scale. I just want there to clearly be 4 intervals that we have to check. Let's see, another thing that I think we could do right away is it's a strict less than, right? It's the values of x for which that rational expression is less than 0. So it's not a less than or equal to, which means we don't have to worry about any of these endpoints here. So open circles everywhere. All right, now we can start thinking about intervals and things. So we're going to have 4 intervals. So we'll have the interval from negative infinity to negative 1, then negative 1 to 3 halves, then 3 halves to 7, and then above 7, so 7 to infinity. All right, then our test values, we're going to need them. And then I guess here we could jump right to the full expression, maybe. That might actually be easier. So we'll just go ahead and do that. Like rather than having the numerator and denominator separate. So the test value for this first interval, I would probably pick a negative 2. It's got to be something less than negative 1. I think that's closest to 0 as you can get. That'll probably make the simplification as easy as we can get it. So we're going to have, let's see, it's 2 times negative 2. So 2 times negative 2 minus 3 times negative 2 plus 1 over negative 2 minus 7. All right, so negative 2 times, or 2 times negative 2 is negative 4, minus 3 is negative 7. So this will be negative 7 times negative 1 over negative 9. So ultimately that's going to be a positive divided by a negative. So this is negative. And so that means that I need a negative up there. And so I guess that's part of our solution. Then the second interval, I would pick a test value of 0. So then you'd have, let's see, 2 times 0 minus 3 times 0 plus 1 over 0 minus 7. So that's going to be negative 3 times 1 over negative 7. That's a negative over negative, so that's a positive. All right, so then that means we're going to get a plus in there between negative 1 and 3 halves. Between 3 halves and 7, I don't know, we could pick something like 4, right? You could pick like 2, 3, 4, 5, 6, anything like that. I'm going to pick 4. And I was going to try to keep those the same color. So if I pick 4, I'm going to have, let's see, so I'll have 2 times 4 minus 3 times 4 plus 1 over 4 minus 7. And then that's going to be, let's see, it's 8 minus 3 is 5. This is 5 times 5 over negative 3. So that's going to be a negative expression. And I wrote way too big here. The last one does end up being positive. I guess I have to do it down here. So let's see. Sorry, this isn't aligned very well, but the simplifying that expression is taking up a lot of space horizontally, I guess. So the last one, we could have a test value of 8. And then for the expression, right, anything bigger than 7 will work for the test value. So 8 seemed like kind of the obvious choice there. But then we'll have 2 times 8 minus 3 times 8 plus 1 over 8 minus 7. So that's going to be 13 times 9 over 1. Yeah, positive number, right? So that's going to be positive. And so then up here where I've got the number line, I guess I just need a plus down at the end. So plus down there. And we just want where it's negative, right? If I go back up to where the original problem was, we want where the expression is less than 0. So we want that first interval and then the third one. So less than 1 and then between 3 halves and 7. All right, so then our solution, that's going to be the set of all x such that, let's see, I guess x would be less than negative 1, or 3 halves would be less than x would be less than 7. So you could write it that way. Or if you want it written as an interval, you have to write it as a union because there will be 2 separate intervals. It would be negative infinity to negative 1 union 3 halves to 7, like that. So yeah, if you can do 3, you can do 4, right? Like this one is definitely shorter, and it's because it's already set up pretty well for going right to figuring out where the divisions would have to be in the number line, where that would have to break up. All right, and then 5 is a word problem. So 5 says, suppose the daily cost C of manufacturing bicycles is given by that function C of x. Then the average daily cost, so like average like per bicycle, would just be that divided by x, since that's the number of bicycles. So how many bicycles would have to be produced each day for the average cost to be no more than 130? So for the average cost being no more than 130, that means that we need C bar of x to be less than or equal to 130, right? That's what no more than would translate to. It can't be bigger. It's okay if it's equal. It's okay if it's smaller. So less than or equal to is what we're aiming for here. So that means that, well, we know what C of x is. We can sub that in. We'll have 50x plus 4240 all over x is less than or equal to 130. But we can solve that, right? If you're going to clear, well, I guess we're not quite there yet. Got to get the 0 over here first, and then we can go from there. So we got to get the 0 on the right side. So if we subtract 130 from both sides, you'd have 50x plus 4240 over x minus 130 less than or equal to 0. But then in order to combine numerators, you're going to need a denominator of x where that 130 is, right? That's going to be your least common denominator. So if you multiply 130 by x over x, you'd end up with 50x plus 4240 over x minus 130 times x over x, and that's less than or equal to 0. Then you could combine the numerators together and say, all right, well then that's 50x plus 4240 minus 130x all over x less than or equal to 0. So then we've got that negative 80x plus 4240 over x less than or equal to 0. All right, so one thing you could do, because right now it looks like you'd say, okay, well, x makes the denominator 0, and then you just have to figure out what value of x makes the numerator 0. Actually, you don't have to worry about the denominator, because the denominator has to be a positive number, right? So that we're not going to worry about. So for that whole expression to be 0, so in order for this to make any sense, x must be greater than 0, which means that in order for the whole expression to be less than or equal to 0, then the numerator's got to be less than or equal to 0. So negative 80x plus 4240 must be less than or equal to 0. And so then basically we can just solve that, which is a little easier since now that's just a linear equation, right? Negative 80x plus 4240 less than or equal to 0. All right, well, I guess we could subtract 4240 from both sides, and we get that negative 80x is less than or equal to negative 4240. Be careful of this next step, because you're going to have to divide by a negative, and so that would mean that the direction of the inequality would have to reverse. So you'd have negative 80x over negative 80 greater than or equal to negative 4240 over negative 80. And so that means that x is greater than or equal to 53. So then what the answer is at least 53 bicycles. So at least 53 bicycles. And that finishes off the live streaming notes for section 5.5.